Okay, it looks like I have the top of the hour on my clock, so we are going to get started to make sure we have time to get through everything today. So welcome everyone. I hope everyone is doing well, especially if you are joining me live on this wonderful Tuesday. Thank you for taking the time to join me about this webinar for improving infrastructure resilience about extreme weather. So I am your host, Sam Justice, and I'm a licensed professional engineer in the state of Wisconsin and Kentucky, and I have degrees in civil and geotechnical engineering. I am one of the engineers here at Presto Geosystems, and we manufacture erosion control, stormwater management, and porous pavement products, all made in the upper Midwest of the United States. Through an extensive national and international distribution network, we offer technical and site support, as well as free project evaluations from our in-house engineering team, including myself. So, learning objectives, some of the things that I hope you get out of today's presentation. Understand how our products can provide permanent solutions for building roads as well as alongside roadways. Understanding how geocells can work in challenging soil environments. Learn about the different applications where geocells can be used, and learn how they can help manage stormwater and stabilize slopes in your right-of-ways. And learn how the GEOWEB system can help manage stormwater and mitigate your flooding. So first, a little bit of background about Presto Geosystems. We worked with the U.S. Army Corps of Engineers to develop the geocell technology in the late 1970s and have been innovating in this market ever since. Our products have been used in nearly 200 countries and in every state in the U.S. We go beyond simply providing a product. We help provide you a complete stabilization solution. So we do operate in three main product areas. Soil stabilization using our GEOWEB Geocells. Those can be used for load support, slope and channel protection, and constructing green retaining walls. And we also have a porous pavement section where we offer both vegetated and aggregate solutions. And then finally, lightweight reusable construction mats. So today we are focusing on using the GEOWEB Geocell system. We're not necessarily going to be talking about those other products, but if you do have some questions about that, feel free to reach out to me once we're done. So now we're going to cover some general information about the GEOWEB system. If you are not familiar with geocell technology, what it is made of, how it works, that sort of thing, we're going to get you all caught up. So the GEOWEB system is our version of the geocell technology. So GEOWEB Geocells, and it consists of two main attributes. The first is going to be the cell or the container size. The cells come in three diameters, small, medium, and large openings, with cell heights of 3, 4, 6, 8, and 12 inches. So the dimensions that you would choose, the size and the depth, are going to depend on your project-specific details and if you have any vehicle loading requirements. And we can help you determine which one is going to be the most appropriate for your specific job. There are also 5 section lengths, so how big each panel is, to best fit your project needs. So you can imagine that there is no one right size fits all. We're going to help you determine which one is the best one for you. Another thing I want to point out is going to be the ultrasonically welded seam. And that's going to be where all of the connecting points are. And it's very important to the function of a geocell. The stronger the seam strength, the better the performance that the geocell is going to have. A strong seam allows for heavier infill materials, steeper and taller slopes, and better lifetime performance. The GEOWEB panels are produced using a high-quality virgin high-density polyethylene HDPE resin for consistently strong welds at every cell junction, while also maintaining semi-rigid ductile properties within the cell walls, having high stress crack resistance, and having overall toughness and long-term durability in the environment. Our geocells do not use any fillers or exotic polymer alloy blends, which can ultimately reduce your weld strength, and it can reduce other properties as well, such as your environmental stress crack resistance. Having these sorts of things, fillers, alloys, that sort of thing, are offered in some of the competing geocells that are out there on the market in the name of increasing cell wall stiffness, so increasing a single parameter of the system. So to avoid weld failures and the damaging effects of differential settlement, uniformity in performance across all elements of a geocell system is going to be more important than the stiffness of the cell alone. And so that's kind of what we want you to take away from this, is the idea of uniformity of performance. You don't want to highlight a single property or mechanical function of the geocell to the detriment of other functions. So that's sort of what we're going to come back to as we continue talking about geocells, the GEOWEB system, how it works, uniformity in performance. So I did mention there were two main attributes though. So the second main attribute of the GEOWEB system is going to be the infill material. So what you're putting into each one of those containers. An important benefit of the GEOWEB system is that even a low quality aggregate, a sand, or even salvaged materials can be used to infill the cells. So using salvaged aggregate or sands that you find on site can save significant amount of money on material and hauling costs. And we can also have you eliminate the fines content of your material when desired, since the cells provide the confinement and aid in compaction of those cohesionless materials. That's how you can use those sand particles. If you do remove the fines content, you can significantly improve the drainage and let the water flow freely through the system, preventing pore pressure buildup and the global failure across the cross-section. So the ability to use those sands and low-quality aggregates really sets the 3D GEOWEB system apart from things like planar geogrids or geotextiles. Those type of products typically require a high-quality material with really high friction angle materials to achieve their optimal performance. With the GEOWEB system, low friction angle materials are just fine, and the GEOWEB panels will still achieve their full potential even when you're using those poor quality materials. So again, big cost savings are available there. One thing to point out, it's a pretty big buzzword in a lot of media now, is microplastics. So the GEOWEB panels are made from a high stability inert material, that HDPE resin, and they are your permanent stabilization solution. They're not going to degrade, leach, or release microplastics into your environment. The GEOWEB panels are manufactured with that HDPE with no fillers, polymer alloys, or compatostabilizers. Nothing in there to mess up that might release those microplastics. So our base resin is actually the same material used in environmental applications such as geomembranes or environmental barriers. And those can be used to protect against the spread of harmful toxins. And so all of our products have been third-party tested by accredited geosynthetics laboratories, confirming long-term stability against environmental factors such as weathering and oxidation. The GEOWEB system is predicted to be durable for up to a minimum of 100 years in natural soil based on analysis in accordance with EN ISO 13438, and when subjected to UV radiation and accelerated weathering conditions in accordance with IN 12224, the GEOWEB specimens retain 100% of their original tensile strength with no loss of mass or change in visual appearance. So all of that to say, you're not going to lose any material and it's not going to degrade or become less functional over time when exposed to the elements, which it's going to be. It's going to be buried in soil. It's going to see sunlight. It's going to have all of those things which could potentially, in lesser quality materials, release those microplastics, leach some chemicals into your environmental system, anything like that. You don't have to worry about that with the GEOWEB system. We've done the testing, we've proved that it's worked, and we can show that it is safe for the environment. And the GEOWEB system and all of our accessories are 100% made in the USA under strict quality assurance and environmental control processes. So they are sure to comply with all requirements for the Build America, Buy America, BABA, and the Infrastructure Investments and Jobs Act, IIJA. So if you are looking to get some of those federal dollars, especially if you are working on, say, a DOT job, or if you're looking for anything where you're trying to get that grant money, the GEOWEB system and all of our accessories do meet those requirements. We are made 100% in the USA and are happy to help. Okay, so that was the GEOWEB panel itself. But we do have some system components that are all supporting pieces that help the GEOWEB panels protect your project area. And they also ensure that uniform performance of the interconnected system. So again, hearing that word uniform. So protect against those damaging effects of non-uniform deformation or differential settlement in response to your applied loads. So if we think back a couple slides, the GEOWEB panels themselves do come in discrete sections, with the average size being around 250 square feet. Your project is most likely going to be bigger than that, so multiple panels will be required to cover your entire area. The ATRA key is going to be our first component for that completely integrated system, connecting each individual panel of the GEOWEB system into a single web that covers your entire project site. It allows for faster installation of the GEOWEB and will last the lifetime of the project, ensuring that your area is protected and that the GEOWEB system is not going to fail under anticipated loads. The specific engineering values of the ATRA key will ensure that the system holds up to loading over time without corrosion that you would see if you used metal staples or the failure of underperforming cable tie systems. So those are used in some of the competing lesser quality geocells that are out on the market, and our specification sheet calls out the specific engineering values for this patented connector so that you know you're getting the right material to help hold everything in place. Something else we offer is the ATRA wall key. So you can see it's a very similar option. It is the major component for a completely integrated earth retention system. And it is used to connect adjacent GEOWEB retaining wall sections through the material. So the ATRA wall key includes the integrated washer at the base of the handle for coverage of those connection locations, has frictional barbs for improved interlock with the GEOWEB sections, and has an ergonomic handle with the S-shaped contour for ease of installation. So it is formulated to withstand weathering and ultraviolet radiation, so UV radiation, same as the GEOWEB panels themselves. So the ATRA wall key will not corrode or photodegrade even when exposed to very harsh environmental conditions. Securing sections with the ATRA wall key is faster than using staples or zip ties, requires no tools, and can be easily completed by a single installer in one easy turn. Next, if we are going to take a closer look at some of the anchorage options. So if the GEOWEB panels are laid completely flat, gravity is going to do all the work. You don't need to help anchor it in place. However, if you are putting it on a slope and that angle starts increasing, you are going to have to start using some sort of anchorage to hold the panels in place and make sure they don't just slump all the way down to the toe of your slope. So for shallow slopes, which for us is going to be around a 2 horizontal to 1 vertical, about 26 degrees or shallower, you can use stake anchorage, and that's usually going to be sufficient to hold the panels in place. We do have 2 options for stakes, one with the standard steel rebar, another one made of completely HDPE, which is shown in the photo here. So if you're in a saline environment, say you're along a coastline, the HDPE speed stake is going to be a lifesaver compared to your corrosion-prone steel. And the stakes can be driven by hand or by power tool for easy installation, and we can help you with that installation if you are concerned. Then if you do have some steeper slopes, so if you're going greater than a 2 to 1 slope, all the way up to around a 1/2 to 1 slope, which is going to be around 60 degrees is about our max for slope stability, but we can always work on that on a case-by-case basis. But if you do have that really steep slope, or if you're in an area where you can't puncture your surface, if you say are over a geomembrane liner, you don't want to be punching holes through that. So you're going to want to use a tendon anchorage system. So our ATRA tendon clip transfers the load from your heavy infill material to the tendons and then up to your crest anchorage system. So if you are doing that, you're going to put in a dead man pipe, maybe some earth anchors, embed it into existing structures with concrete anchors, something like that. And the ATRA tendon clip is specifically designed to fully transfer both safely and securely the forces placed on your geocell. Every accessory that we have and every feature that they have has been designed and tested specifically to work together with the GEOWEB panels so that we can go from problem to recommendation to construction solution with a system that does model real world forces. So we actually know that these things work. We've done the testing. We have field experience. We have decades of successful projects. So we know that our accessories are successful. So one last thing I want to point out is this is our quick product specification for the GEOWEB system. And I'm going to just highlight a couple things here. again, for how a geocell system can perform uniformly. And it is critical for both the factory welded junctions, so those ultrasonically welded seams that we talked about, and the field joint junctions, your mechanical junctions, the key. They all need to perform at a level that is commensurate with the cell walls. So you have those three primary elements of a geocell system: the cell walls, internal junctions, and mechanical connectors. And they all have to perform uniformly as a complete system. So therefore, an incremental improvement in a single characteristic, i.e. your cell wall stiffness, is only valuable if there's a complementary improvement made in those other two components of the system. So like I said, the GEOWEB system is manufactured using that proprietary blend of high quality virgin HDPE material, and our formulation has stood the test of time for more than 40 years and contains no fillers, unstable polymer combinations, or exotic polymer alloy blends. And for most typical sites, the GEOWEB system will retain its durability for more than 50 years. That's what we've seen in the field, with lab testing indicating greater than 149 years without degradation, even at full exposure to the elements. So we haven't reached 149 years old in the field yet, but we're working on it. And so we stand behind our numbers so that you can deliver certainty in a solution as you build with materials that you can trust. Okay, so with some of that background out of the way, let's move on to discuss how the soil stabilization capabilities using the GEOWEB system work as they relate to some load support applications. So Presto offers some solutions for many different types of road and highway applications, including load support for unpaved roads, so gravel or stone surfaces, road shoulders, and base stabilization underneath paved roads. And stormwater control is going to be possible when using the GEOWEB Geocell system through roadside ditches, drainage channels, and culvert outfalls. So the purpose of cellular confinement is pretty simple. You want to stabilize the movement of unstable soils, both horizontally and vertically. The weaker your subgrade conditions, the more practical it becomes to insert the GEOWEB system into your cross-section. It is an engineered system integrating multiple types of geosynthetics with the best method of confinement and subgrade stress reduction in the industry. And so although today's discussion is going to focus on the GEOWEB system for a number of different things, we do have some really niche and some more specific applications, including intermodal yards, rail ballast reinforcement, retaining walls, concrete line channels. We're going to cover some of that today, but if I don't get to it and you think that the GEOWEB system is going to be important or could be helpful in your application, please feel free to reach out and we'd be more than happy to discuss. So the 3D GEOWEB system works like this. When the vertical load is applied, the active earth pressures in the loaded cell, the one in the center there, pushes back against the passive earth pressures in all of the adjacent cells to form a stable system. Being confined, the soil responds passively. The infill is limited in its movements, represented by those yellow arrows, and then the cells adjacent to that loaded cell provide that passive resistance, which is going to be all those red, orange arrows. The load is dispersed over a greater area in the lower layers as each cell helps support the ones around it. The GEOWEB cell walls also transfer hoop stress, which is going to be those blue arrows, and that is important for helping keeping the system intact and creates what we call the mattress effect. So the strength of the seams around each cell, the material properties of the individual strips, and the connection method, the key, between the panels are all important factors in determining how the geocell system can improve your load-bearing capacity. Strong seams, semi-ductile resin properties, and integrated connections are all critical to a well-performing system. The GEOWEB system and its accessories are specifically designed to work together to be an effective and permanent solution for roads in soft soil locations. So in the load support scenario, vertical deformation can only occur with either compression or compaction of the soils or through lateral movement of your soil particles. By spreading out the load in a classic granular fill approach, one can reduce the compaction of near surface soils, but only with the GeoCell cellular confinement can one assure that there is no lateral shifting leading to rutting effects. So we call this, like I said, the mattress effect, and it reduces the stress reaching your subgrade. And so here you can see a diagram about those stresses. And you have the unsupported subgrade on the left, and then the GEOWEB reinforced subgrade on the right. And notice how there is a complete elimination of the highest stresses at the surface when using the GEOWEB reinforcement system. The stresses are both reduced and distributed over a wider area, creating that mattress effect. And this effect reduces the stress reaching your subgrade and leads to that significant decrease in deflection and rutting. So by eliminating lateral particle movement, because the soil is confined within each one of those cells of the GEOWEB panels, you can stabilize the surface and eliminate the need for constant maintenance. And so here we see an impressive load support benefit, and this is an 80,000-pound loaded dump truck, so your standard AASHTO H20 loading parameter. And it's on a partially filled GEOWEB panel over a soft subgrade. You can see how the cells push back against each other to support that load, and how only the adjacent cell needs to be filled for support. You don't have to have the entire panel filled in before you can start driving on it. So a great benefit of using the GEOWEB system is that you don't need to have every cell filled in. You can reduce your construction time and materials needed when using this approach. And so the GEOWEB system is often compared to 2D planar geosynthetics, such as geogrids, and they do start off with a similar concept. However, due to the 3D nature of the GEOWEB panels, the integrated infill geosynthetic system acts as a composite layer where lateral earth pressures are mobilized and transferred across a three-dimensional network of interconnected cells, that mattress effect. So because of this phenomenon, lower quality fill materials, often sand or other fill materials that are readily available on site, can be beneficially reused, thereby eliminating the need to import expensive aggregate as required with geogrids. So the GEOWEB system uses a thinner cross-section overall, so a 6-inch deep GEOWEB system is going to be equivalent to a 10 to 12-inch geogrid system. We also can eliminate the fines content when desired, since the cells provide the confinement and aid in compaction of those cohesionless materials. And without fines, you can significantly improve the drainage and let water flow freely through the system, preventing pore pressure buildup and global failure. Additionally, geogrids do very little to stabilize the surface of the aggregate, requiring significantly more maintenance over time, since the aggregate is loose at the surface and can get pushed around by vehicle passes. And so continuing with the theme of unpaved gravel road surface applications, a washed or clear stone can be used in the GEOWEB system, allowing you to build a stable, permeable, low-impact development access road. Site access roads, both temporary and permanent, are really common applications with the GEOWEB system. And as mentioned, heavy loaded vehicles can drive on the GEOWEB system immediately after infilling to finish construction. So they can be their own access road during the installation process. So a huge construction time saver. With the GEOWEB panels and a woven geotextile underneath, which you can see at the very bottom of this picture, that's a woven geotextile underneath the panels, you can bridge soft, wet ground, creating access roads with little to no disturbance of the surrounding areas. Saturated soils usually can't support really any type of vehicle loads, but with the GEOWEB system, it can. And the woven geotextiles can add an additional strength layer to the system, and they won't get clogged by your subgrade material, while still allowing water movement as necessary. And again, we recommend using a clear stone infill, and that is combined with the perforations within the GEOWEB cell walls to allow water to flow freely both vertically and laterally through the system, limiting the impact on sensitive environmental locations in ways that paved asphalt or concrete roads would not. So this was a project for Duke Energy down in Florida to install some new transmission towers through the wetlands areas. The high winds of Hurricane Michael had demolished more than 100 towers in this area, all of which had to be restored over this extremely soft subgrade. You can see how easily people were sinking in based on those deep footprints. Imagine how bad it is trying to get some heavy vehicles. So the GEOWEB system was used for both the access roads and as the pads around the tower for maintenance. So the saturated sand really couldn't support any type of vehicle load. So we recommended using an enhanced woven geotextile placed over the subgrade so that you can have that water flow through it, but still have a little bit of additional support. And then the GEOWEB panels were filled in with that low quality aggregate, which they had on site, which could be easily sourced and transported to those remote locations. So they didn't have to truck in a lot of high quality engineered aggregate. they were able to use local material and save on that cost. So once the panels are installed, both wheeled and tracked equipment can drive over these systems easily, even when the infill material is sand or otherwise low quality stone, which would normally be horrible to drive tracked vehicles over. And again, you see how the GEOWEB panels can act as their own access road, so you just keep filling up the cells in front of you. No need for additional temporary roads. So that was how the GEOWEB system can be placed on flat surfaces and support vehicle loads. We can also move on to embankment stabilization using the GEOWEB system. Many times, slopes or embankments need to be stabilized after or in conjunction with road and highway construction. So the GEOWEB system for slopes can be filled with several different materials depending on your project needs. Topsoil with vegetation is probably the most common, but sometimes vegetation is not appropriate. So you can also fill in with stone or with concrete. So this is a pretty simplified diagram showing how the different system components interact with the GEOWEB panels to form that complete system. So again, you may need to put down a geosynthetic layer, such as a geotextile. Not always necessary, and especially if you are trying to grow grass, you're probably going to want to not use that geosynthetic, but it is an option to put it there. Then you're going to lay the GEOWEB panels on the slope surface, and note how the GEOWEB has that horizontal turn near the top of the slope. This is important for crest anchorage and erosion control. And we talked about it earlier, a couple options for anchoring. You can use stake anchors, either the steel rebar or the HDPE speed stakes. Those are for those shallower slopes. Or if you are going to have a steeper slope, or if you're over a geomembrane, otherwise can't use stakes, you're going to use a tendon system and tie it off to a crest anchor, such as a buried dead man pipe. So the GEOWEB system works in multiple ways to protect your slope surface. Most importantly, it prevents significant movement of the soil by confining that soil into the individual cells or containers. So by separating the soil into those smaller segments, the system resists mobilization of the entire slope face due to hydraulic loads, preventing soil erosion. And it's important to reiterate that the proper installation of the GEOWEB system includes embedding the panels into the crest of the slope. And that's to prevent water from flowing underneath the GEOWEB panels and undermining the system. So you don't want rills or gullies forming underneath the panels. And the system provides a way to fully vegetate slopes that otherwise probably wouldn't be able to support plant life, and increases the overall slope stability by interlocking with the vegetated root zone. You could also have stone or concrete material as your infill, again on slopes that would normally be too steep to allow for natural stone surfaces. As I said, vegetated slopes are probably the most common option just because they can result in the most attractive looking slopes, and those are going to have very little maintenance. You don't really need to go in and worry about, regrowing grass every year. So this was a vegetated slope over an unstable soil slope at an active gold mine in northern Canada. Had some variable slope angles along the face, and an access road is going to be built above the slope where that excavator is currently shown. So the slope had to be stable enough to support those expected road traffic loads. And you can see we have some space constraints at the toe of the slope as well in the form of another access road. So the slope couldn't be regraded into something gentler that would be able to be naturally stable. That's why the GEOWEB system was included. And so we have a nice sort of feature of the GEOWEB slope shown in the after photo, the little inset there, where a guardrail was also installed along the crest, and then a fence was installed along the toe. So there's no limit to this sort of infrastructure being installed near or on the GEOWEB panels. So it's really a great benefit for tight spaces like this one. So this was a slope alongside a road in Ohio, and it shows a pretty common problem that can be solved with the GEOWEB system. Erosion and washout of soil slopes onto road surfaces is a problem in a lot of locations. So covering the slope with the GEOWEB system and then filling it in with topsoil and allowing for vegetation to grow, you can now eliminate the concern of having to constantly replace that soil after storm events. So we do recommend some sort of surface protection, such as hydroseeding or using biodegradable erosion control blankets over the panels until that vegetation has a chance to grow. Especially if you use something like hydroseeding, that vegetation is going to start growing really quickly. You don't have to worry about it in the long term. So embankments alongside roadways You have to deal with sheet flow runoff from your impervious surface, like this slope here. This was done in Maryland for the State Highway Administration. So sheet flow off of an impervious surface can cause sloughing of large sections of the upper layer of topsoil, can cause some deep rills or gullies, and will prevent vegetation from taking hold so it can't naturally support itself. The GEOWEB system will hold that soil in place while still allowing the water to run over the surface, so you're not going to get any more gullies, and it'll give the vegetation a chance to form those deep roots to help further stabilize the soil. Road widening is becoming a lot more common, with state DOTs trying to find more roadway space without displacing any significant infrastructure. So slopes and embankments are usually where that additional space is going to be found, such as this road widening project in New Hampshire. So the GEOWEB slope protection system allows for steeper slopes to be created without those erosion concerns. The system can be installed quickly, and then vegetation will grow very fast after that. So there isn't a long construction time that may shut down your important roads. Ease and speed of construction are important features of the GEOWEB system that everybody can appreciate. So this was a project down in South America along the Zaramilla River between Peru and Ecuador. So I did say it's not just a US product. So the river is full of mangroves, and the currents can pretty easily pick up sediments in soil, eroding the banks and threatening infrastructure. Extreme El Nino events have caused some pretty catastrophic flooding in this region, and climate experts predict more severe storms from the Pacific in coming years. We all hear of those predictions, and it's never good predictions, so this is always a good thing to try and help mitigate those or help prevent that erosion before it happens. So during a brief dry spell, the river banks were cleared and regraded to allow for the installation of the GEOWEB slope protection system. The system also provides excellent resistance to sheet flow, preventing the formation of those rills and gullies I've talked about, especially in areas of concentrated flow over erosive soils. So for many areas of this particular project, protection of the slope allowed for the construction of steeper embankments with less horizontal footprint, thereby conserving valuable land space. Contractors installed approximately 2.4 million square feet, so around 230,000 square meters, of the GEOWEB system along the compromised riverbank slope. Installation rates are usually around 1,300 square feet an hour for a crew of 4, including your operator. And for the Zaramilla project, the contractor further optimized installation rates by pre-staging sections and assembling the system on the crest before expanding the panels downslope. And for this case, the GEOWEB shoreline protection system used a concrete infill to help protect the riverbank against future storm events. So the GEOWEB system with concrete infill provides an economical hard armor protection of slopes and channels exposed to really high flow velocities and high shear stresses. So the system has been proven to withstand flow velocities of over 36 feet per second, around 11 meters per second, outperforming riprap, gabions, and other conventional hard armor strategies. So the quality, surface finish, and thickness of the concrete can be selected to meet specific design needs. And concrete-filled GEOWEB system comprises flexible, poured-in-place sections that are more economical than articulated concrete block systems, ACBs, and don't require specialized equipment to install. The GEOWEB shoreline protection system is quick and easy to install and does not require any specialized training. The complete system is formless and poured in place, eliminating the need for conventional concrete formwork or rebar reinforcement while still ensuring consistent pour depths. The whole project took about 4 months to install, including excavation work, and the system becomes a flexible concrete slab that conforms to minor subgrade movement and prevents uncontrolled cracking and reduces the potential for piping and undermining. This work can also be integrated into existing infrastructure in the area. The GEOWEB protection was placed up against bridge abutments and formed around culverts and other drainage areas. So you don't need to redesign what's already in place. You can work with roads and bridges and landscape elements to create your final solution. And with concrete, it is a permanent solution, even against the more extreme weather events that are going to happen in this region. So the GEOWEB shoreline protection is performing to expectations in this area and is going to provide some much needed protection to the Zaramilla River and the communities that depend on it when the next major storm hits. This is what it looks like after everything is in place and the water is brought back in. So if global stability is a concern, or if you're steeper than about that 60-degree slope angle that I mentioned, embankments really should be built up as retaining walls. So not just surface protection, but actually building up retaining walls so that you can have that global stability. And so the GEOWEB panels can be stacked vertically on top of one another to create a gravity retaining wall. And then you can also have geosynthetic tieback reinforcements added if necessary, similar to an MSC block wall or a gabion basket wall for that type of internal reinforcement. And then the walls can be filled with topsoil in those front cells to create living green walls, or stone or concrete if you're going that direction, and can be built to support vehicle or building loads. So like I said, there were two main options for walls with the GEOWEB system. Gravity walls, you can have slightly longer pieces that you would build up sort of as a triangle, so longer at the bottom, narrower at the top. Or you have geosynthetic reinforced. You're going to have geogrid tiebacks. You can have soil nails or rock anchor tiebacks, something along those lines that will provide some extra internal reinforcement. So in either case, the front cell can be filled with topsoil, stone or concrete, and then the back cells and the area behind it are going to be filled with a drainable material so that you don't have that pore pressure buildup. So we're not going to really talk more about the design and construction of these today, but it is a fascinating topic and something that requires a lot of information. So if you are curious, we do have webinars on this, or you can feel free to reach out to us directly and we'd be more than happy to talk about it. So GEOWEB walls are the preferred solution when you're dealing with poor soils with significant settlement potential. And GEOWEB retaining walls actually saw a major earthquake in Japan, resulting in the sliding of the entire slope area. So you can see the GEOWEB wall system sustained no damage, but those concrete flumes were definitely broken. Not going to be able to use those anymore. So think about how a rigid concrete MSE wall would have been damaged in the same way. Potentially significant failures downslope, who knows what would have happened, but you don't have to worry about that with the GEOWEB system. It can handle those forces of an earthquake, still be good to go, still hold that slope in place. So this was an Ohio DOT project. It is actually a 20-foot high wall constructed to keep a rock face from further erosion. The GEOWEB system is actually a fascia that helps protect that road without taking up a lot of horizontal space. So this is a great option if you know that you have unstable rock walls or steep soil slopes in seismically prone areas. Not that Ohio has a lot of seismic area, but it is something to keep in mind. And the GEOWEB wall can support and maintain that wall face during normal times, and after a good ground shake, the GEOWEB wall is still going to be in place and can help prevent rock falls or landslides from compromising your roadway. And the GEOWEB system also works great along shorelines of stormwater channels. Placing the panels along a shoreline will help against erosion due to water movement and wave action. So this project was along a stormwater diversion channel that helps move hurricane waters. So during the hopefully infrequent hurricanes, the channel would flood, and it was severely eroding channel side slopes each time. So obviously there's some infrastructure on either side that you want to help keep in there. You don't want that to happen. So this is what it looked like during some flooding. So waters come through. You can see it must have been in the winter. There's not a lot of vegetation growing, but it is helpful to know that you can do that. So you have vegetation on the outside, make it look nice, especially when there's some nice grass growing, trees are blooming, all that good stuff. And then you have that drainable material in the back. So you can see that in the right-hand photo. That's going to be your good clear stone. Allow that water to flow through. You don't get poor pressure buildup behind the walls. You can also add drainage tubes, weep holes, that sort of thing to help manage that stormwater as well. So here's what it looks like totally flooded. So this was after a very large storm event. The water comes pretty much way up higher than a person could walk through, but that wall is going to still be stable. And you can have a slope above the wall. So it helps with grading plans there as well. And so you can have the GEOWEB wall on a single side of the embankment like this one, have a natural embankment on the other, or you could have the GEOWEB on both sides of the of this channel. It's totally up to you, allows for a lot of flexibility in your final project design. So this was a fun project. It really shows the durability of the GEOWEB wall. This was a small town in northern Iceland, and they wanted a more permanent avalanche protection wall. So without it looking too unnatural, as much as a built wall in the middle of nowhere can be. So that's where a vegetated GEOWEB wall came in. So this wall was built from the ground up, completely freestanding, rather than integrating it into an existing wall or slope. And so the wall did have to be built so that it would protect the majority of the town from the most anticipated avalanche direction. So the GEOWEB wall curved and moved with the landscape to cover that. The internal strength of the GEOWEB wall was enough to withstand the first big impact of snow, and then the structure had to be high enough to allow for significant buildup of snow during your avalanche event. So access roads were built around and on the top of the wall to make the structure stay clear of obstacles, and so it can be cleared up after those snowfall events. So here it is. You can see the grass is starting to grow, getting green. It's going to cover all of that black plastic, so it has that potential to look slightly more natural, again, as much as a built-up wall can be. But now the town has their permanent solution and protection for their own extreme weather challenge. So every town, every city is going to have their own specific and unique challenges, and the GEOWEB system is going to be able to help you withstand some of those. Okay, last topic for today is going to be using the GEOWEB system for stormwater control for mitigating flooding after a storm event. So GEOWEB channel protection is very similar to slope protection, covering, you can cover the entire channel or just a single side slope. And the GEOWEB system can handle both continuous or intermediate flow, low to high flows, and a variety of channel dimensions are possible. So this system is more economical than solutions that utilize large riprap stone or heavy gabion baskets, and several different infill material options are available to meet any channel flow needs. We have done some pretty extensive research performed at Colorado State University to show how the vegetated GEOWEB system can perform in channel conditions compared to riprap. And what we determined was that when paired with a strong surface protection, the GEOWEB system can resist extremely high flows, allowing for velocities of up to 30 feet per second and some pretty high shear stresses. So we also did testing for stone infill and concrete. We have that information available on our website if you are curious. It's some pretty good information to have. So this was a stormwater channel down in Florida. Again, it had some pretty severe erosion during storm events. The water flow here fluctuated pretty drastically due to those storm events being very low during normal times and then rising very high and having very fast flows during storm events. Was wreaking havoc on those side slopes. You can see there's roads, there's buildings, things that you don't want to wash away or have impacted by that erosion, so the GEOWEB system was brought in. So the panels are placed both above and below your average water line for this type of project. And those panels do need to go below the water line to ensure that they don't get lifted up due to wave action, and so that they're protecting that entire shoreline all the way down to your channel bed. So the area does not have to be dewatered for this type of installation. The panels themselves are going to float initially, but will eventually be staked down to hold them in place. And then once you put your infill material in, that's going to hold everything in place. The system is not going to go anywhere. So dewatering is helpful, but not necessary. And so here you can see that final surface after vegetation has been established. The performance of the GEOWEB allows it to handle fluctuations in water depth and the associated velocities and shear stresses that come with that, while still preventing erosion on your side slopes. And using a grass and a soil and a grass that's local to your area, maybe even your salvaged material, we've talked about that, reusing what you have on site, it's going to help with blending in the system so that the GEOWEB panels aren't noticeable. But now you can walk along this shoreline without fear of sinking in, and the shoreline is protected from erosion for years to come. So channels can also be filled with stone or concrete, like I mentioned. Stone infill is going to be appropriate if you're in maybe an arid environment or otherwise don't believe vegetation is going to grow in your area. And it's also important to keep in mind that vegetation isn't going to grow in standing water. So if your channel does have a consistent water level, stone infill may be required underneath that mean water level, and then you could put vegetation above it. Then concrete infill is going to be the choice when you know you're going to have those really high flows. There are no restrictions in terms of flow or shear stresses when concrete infill is used, so definitely put it in those high flow areas. Steep channels or high flows after storm events are when concrete would be helpful. You can also include baffles or energy dissipators in the GEOWEB channels to help reduce that flow over time, and that integrates very easily with the GEOWEB system. So this was a stormwater channel project that shows how the GEOWEB retaining wall system can be used in those water flow environments. So the stacked system can be used in urban areas where there's little to no room to lay back your side slopes, or in order to handle more volume in the same footprint. So great along roadways and highways. Vegetation can be used above that water line for a natural look, with stone or concrete being used below the water line to help resist erosion and washout. And the GEOWEB system can be used in conjunction with riprap, where there's the potential for very high flows, like this culvert outflow in Milwaukee, Wisconsin. So in this case, they already had the riprap in place, but they wanted to protect the areas above the riprap in case there was a very high flow event. So a strong surface protection over the panels, such as a turf reinforcement mat, can be used to help withstand those high flows while still allowing for full vegetation growth. And note that something like this is intended for those short duration but high intensity storm events rather than continuous flow. And the flexible GEOWEB panels can easily accommodate infrastructure such as culvert pipes or other obstacles so that there are no gaps in your protection. And including something like a sonotube can allow for the installation of guardrail posts or underground infrastructure such as cabling. We often hear from contractors how easy it is to install the GEOWEB system even when they've never worked with it before, and how it goes in place much faster and easier than things like gabion baskets or H-pile walls. And we do have both written installation guides and tutorial videos that you can use, as well as providing on-site or personalized virtual assistance when required. So in summary, every project is different, but the GEOWEB system is going to have the right solution for you. The GEOWEB system can be added alongside road projects for more stable and longer lasting surface courses for unpaved areas to reduce your maintenance and repairs. You can also put it underneath paved surfaces, alongside roadways, in road shoulders and drainage ditches. You can use it on your side slopes to help prevent erosion. You can use it as retaining walls, both freestanding or in channels where there's going to be water flow. Lots of different options for the GEOWEB system. It's very flexible, and it does give you a complete system solution for ease of installation and peace of mind. So part of our complete solution is our technical assistance. The engineering team here, including me, are going to work closely with landscape designers, engineers, contractors, project owners. We do offer a free project evaluation service for any type of GEOWEB project. The form is on our website, prestogeo.com. You fill it out with as much information as you have. You can attach documents such as geotechnical reports, project site photos, and other information, and then it comes directly to us. And pretty quickly, 1 or 2 business days, we turn it around, and we're going to give you our complete evaluation, including our infill recommendations, anchorage requirements. We're going to give you some other documentation that you can include in bid documents, that sort of thing. We're going to work with you to get the best solution for your project. I also want to highlight our Presto Geo P3 online tool. It does help with custom calculations. It has a great resource library. You can get support from our on-staff engineers. It's a great tool, offers a suite of geotechnical calculations, including geocells for load support, and allows you to run a lot of iterations on your own without having to constantly come back and wait for our engineers to get back to you. You can do this on a much faster basis. So again, that's prestogeop3.com. And we do deliver quality and over 40 years of expertise, guaranteeing each shipment meets or exceeds our specifications so that you can deliver certainty and build with materials that you can trust. No disclaimers, no concerning fine print. And a little bit of housekeeping as I finish here. So we've made it faster and easier for you to obtain your PDH certificates. With our webinar dashboard, you can easily view our library of webinars and download webinars that you've completed. Our dashboard keeps a record of any on-demand webinars that you've watched, as well as your PDH credits earned. And please note for certificates for the live webinar. So if you did join me on Tuesday, May 7th, your PDH certificate is going to come from GoToWebinar. So you're going to get an email with that showing you how to download your certificate. That's going to come from GoToWebinar. You should have it by the end of the day. And then in a couple days, you will receive another email from Presto Geosystems with information about the webinar dashboard, other helpful documents that you might be interested in. So you're going to get 2 emails, GoToWebinar by the end of today and Presto Geosystems by the end of the week. And if you don't receive either of those emails, check your spam folders. We all know how things can get caught there. And so that's my presentation. My contact info is here. If you do have any questions, I am going to go through some of the good questions that look like they came in. And the questions are going to be recorded and put on the webinar dashboard. So if you do need to go, I fully understand. Thank you so much for joining. Feel free to log on to the webinar dashboard in a couple days. This recorded webinar is going to be on there. You'll be able to skip to the Q&A session at the end. Okay, so let's look at some of these questions. So questions about the material that the GEOWEB system is made of. So I mentioned it was made of virgin high quality, high density polyethylene, HDPE. And the question is, do you ever use recycled materials? And so we do actually use recycled HDPE for our porous pavement and our construction mat products. We didn't cover those today, but we do have webinars and lots of good information about those. So those use recycled HDPE. We don't use recycled HDPE for the GeoCells. And the main reason for that is the ultrasonically welded seams, those internal junctions of the GeoCell. When you use a recycled HDPE, you don't have specific quality control to ensure that all aspects of the HDPE is going to be the strength that you need it to be. And so you could potentially have weak points at those ultrasonically welded seams, which would then obviously be a weak point for the system overall, potentially leading to failure. Obviously, we don't want that. By using a virgin HDPE resin, we have that control, we have those standards that says we know for sure, based on testing, that the seams are going to meet or exceed this strength every single time, no potential for those weak points. So that's why we don't use recycled materials for the GeoCells, but we do use them in our other products. So we are trying to make sure we're being as environmentally friendly in that aspect as we can. So a couple questions about the infill materials that you would use. So when would you choose to use topsoil with vegetation versus stone versus concrete? How do you put that on slopes? How do you drive on it? That sort of thing. So a number of questions along those lines. So topsoil with vegetation, granular materials such as stones and sands, and then concrete are the main infill categories that you can use. When you're driving on the system, typically we're going to see you driving on a granular material, a stone or a sand. You can have it be a vegetated surface if you want. So if it's going to be something you're not driving on very frequently, maybe it's a church parking lot that people drive on once a week to go to church, or it's the access road to a electrical tower that you only drive on very infrequently for maintenance. You can have those be vegetated within the GEOWEB system. So that's something that we can help you determine whether or not you're going to be able to support your vehicle loads with vegetation, or if you're going to need the additional strength that stone or sand gives you, but it is definitely possible. You can also have a mix of infills. So if you are creating a drive lane, you can put a granular material along the drive lane and then have vegetation on the shoulders of that drive lane, all within the GEOWEB system. So it's all confined and has that strength. That's a nice way to sort of make your area look a little nicer and make it not all just look like it's a drive area. You have that nice little bit of vegetation on the verges. So that's definitely an option. On slopes or in channels, when you're not just on a flat area, you're basically going to take whatever your infill material is, topsoil, stone, concrete, and go from the crest to the toe, install from there. So basically you're dropping the material from the top to the bottom and letting it flow down to the bottom, filling in all of those cells. The steeper the slope gets, it does get a little more construction intensive to try and get that infill material in there. But we've seen slopes, as I've said, as steep as around 60, maybe even 65 degrees, is pretty much as steep as we're going to recommend for using the GeoWeb system. And we've gotten those infilled with both topsoil and stone before. Excuse me. So it is definitely possible. Just know that it is going to be a little bit more construction intensive to do something like that. Some questions about how does the GeoWeb system handle water flow? Looks like some of these came in before I got to that near the end of the presentation, totally normal. But yeah, so it does really well with water flow. Like I said, we have done our research and testing with Colorado State University that shows the type of velocities that can be withstood, shear stresses, that sort of thing. And it does really well. And so you don't need to be in a perfectly dry environment to install the system. So if you are going into a channel that has a consistent water flow, you can install without doing that dewatering process, save you time, energy, headache with not having to dewater. Or if you have, like the Zaramila project had a dry season where the water level really drastically dropped, and it's a little easier to make sure it's a dry environment, also totally possible. But the GeoWeb system can be placed on flat areas, slopes, can be built up as retaining walls, and all have that water flow over it very well. I do encourage you to either watch some of our other webinars, look at our research that we have on our website, or reach out to me directly if you do have questions or concerns about how the GeoWeb system handles those wet environments. It is something we have a lot of experience in, but I know it also comes with a lot of questions, especially from regulators, and you know, your local area has all their standards they need to meet. So we're more than happy to discuss that sort of thing with you. Couple questions about very harsh environmental conditions. That's kind of interesting. So yeah, so the GeoWeb system is made of that HDPE material. It's chemically inert, so it's not going to react with environmental conditions. So if you do have a saline environment, so you're going to have, if you're on a coastline and you know that you're going to have that, you know, the salt water come in, not going to be a problem. If you're in a really acidic soil, you know, if you're working in a mine environment, sometimes they use some acids to help with the mining process. That's going to not have a negative effect on the system. It's good to go. If it's exposed to sunlight, so it's got that full UV exposure, not going to crack, not going to degrade. So basically, we've done testing and we have, it's greater than 100 years of no degradation, no material loss, no cracking, anything like that, due to exposure to even very harsh environmental conditions. So it's not something that you're going to have to worry about. This is a great substitute for those type of environments where other solutions may fail due to those harsh environmental conditions. So great questions there. It is not flammable, or wait, do not set it on fire. Let's say that. It is flammable. Do not set it on fire. We've had some people try and put it in areas where controlled burns happen over, say, like a grassland or a prairie area. It is plastic. It is HDPE, which is a plastic. It will melt under fire conditions. So if you know that you're doing controlled burns in that area, it's not going to be a great system. But high heat, if you're in the desert, that's totally fine. You know, being exposed to the sun when it gets very, very warm, that amount of temperature is good. Fire, that's too much. It is going to cause some melting of the system. Something to keep in mind. Let's see. Some questions about how do you put the system in when there's other infrastructure. This is probably our last question because I'm running out of time. So if you have infrastructure around where, say, a slope is going to go, how do you handle that? Or if you need to install infrastructure afterwards, if you've got guardrails or something. So typically we do recommend, as our first sort of recommendation for slope protection systems, having a buried anchored trench at the crest, where you would dig out a trench, you're going to put in a dead man pipe, cover that trench back up, and that's going to be what's going to be the crest support for the system. not always possible to put in an anchor trench. There could be a roadway, building infrastructure, whatever reason, maybe you don't have the space or the appropriate soil to dig that trench. If that's the case, you can use things like soil nails or rock anchors, if that's going to be appropriate geotechnically for your site. If you've got a bridge abutment or a pier or a building right at that crest of the slope, talk with your structural engineer. We can tie off the GEOWEB system directly to that structure. As long as the structure can support the weight of the system, which usually it can, something like a bridge abutment or a pier is usually strong enough to support the weight of the system, we can tie off directly to that. So there are options if you don't have space at the crest for an anchor trench. There are other ways we can get around that. We have lots of experience with that as well. If you have something along the slope face, like I said, geomembranes are pretty common where you're not going to want to put a stake in those, but we also see people wanting to leave, if there's a particularly large tree that you want to build around, or again, if you're trying to put on a slope around a bridge abutment, the GEOWEB panels can flex around those, so they can go around that type of infrastructure or vegetation without needing to remove them, so that's always possible as well. And there are ways to sort of taper the system off around the edges. That's going to be a very case-by-case basis. There's no one right way to do that, but that's something that we can help you discuss. Make sure you get that correct on your plans. Your contractors know what to do with that. So I encourage you to reach out to us directly if you do have that type of installation question. But yeah, I've gone over my time, so I'm going to let everybody go. Thank you so much for attending today and listening to me talk. Please feel free to reach out to me directly or go through our website. We have lots of great information there. And I do hope that you get on some of our future webinars. They also are going to have some great information. And I hope to hear from you soon. So I hope everyone has a wonderful day. Bye.